Hey everyone, Michael Unger here at the H.R. MacMillan Space Center. Happy Earth Day, everyone. I am here in our Ground Station Canada Theater. It's a beautiful sunny day outside in the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. Of course, if you're watching this and you want to get down, we're looking at the sun right now. Our observatory is open. Come on down. We've got a few more time slots to look through that, or you can come tomorrow night because Friday nights our observatory is also open. Today's show is really exciting for a couple of reasons. Number one, it's the first show for our brand new astronomer, Marley Leacock, who hasn't physically joined the team here over on the West Coast, but very soon. How's it going, Marley?
It's going good. I'm really happy to be here. I wish I had sunshine, but all there is in Calgary, where the Bow meets the Elbow River, or the traditional territories of the people of the Treaty 7 region of Southern Alberta, and also the home to the Métis Nation of Alberta Region 3, all there here is snow. So hopefully that melts by the end of the day. We had some slow flurries last night into this morning, but it seems to have stopped for now, but I refuse to say anything concrete because I'm afraid of being disappointed later.
Well, this is perfect. On Earth Day, I think it's only tradition that we should have a variety of different weather here on Earth, right?
Oh yeah, I'm always going to appreciate the seasons, but I appreciate it more when it's in where it should fall, like in December maybe.
Awesome. So, for everyone out there watching, if you have any questions for Marley, Marley is going to answer all questions under the universe as it is our Ask an Astronomer. But because it is a special day, it is Earth Day, we have another special guest, and we're super excited joining us from the Canadian Space Agency, and that is Taryn Tomlinson, who is the director. And get this, her title is so cool, the director of the Sun Earth System Science. Hello, Taryn. How are you?
I am great. I am super. I'm out here in Montreal, and I want to thank the Haudenosaunee Confederacy for their hospitality in this region. This region is snowy as well. And we got tricked into some really nice weather last week. I don't know, Marley, if you tasted spring, but BC, you're making us jealous. You had 25 degrees all weekend. It's tough, but summer's coming. And I'm so happy to be here. I am from Vancouver Island, so
Oh, nice.
very connected to you today. So thank you so much for having me.
Wonderful. And we were just talking ahead of time because I love that picture behind you, which is an actual photograph of the area that you grew up, right?
That's hiking on Vancouver Island, and that's where I transport my mind to every time that I need wellness, brain-friendly feeling. I go to Vancouver Island in my mind.
Wonderful. Well, maybe before we get in, because we are going to be talking all about how the Canadian Space Agency looks back on our planet with some amazing satellites. But maybe first off, maybe just tell us a little bit about your background. Like you said that you grew up on the island. Maybe tell us about that.
That's a great place to take it from, because I remember being a kid on Vancouver Island and spending a lot of time looking up at the stars. And it is a great place on Vancouver Island for stargazing. Marley probably knows that there's not too much light pollution. And I used to spend so much time looking at the stars. And of course, the first one that came out, everybody would get excited. But what I did as a kid is I would look at satellites. I tried to pick out the first satellite I could find. Can you believe that was hard to do when I was a kid? Thousands of satellites up there. It's almost the first thing that you see. And the biggest satellite being the International Space Station. That is just this incredible orb in the sky when it passes by. So growing up, wanted to be an astronaut. I heard that Julie Payette had gone to McGill and did electrical engineering, so I wasn't very creative about it. That's what I did. I thought it was a good idea.
Wonderful. And so as being like, how do you become a director of Sun Earth System Science? I mean, this is something that if I knew this was a title, that's what I would have wanted to do.
I have to say, I am surrounded. My group has 35 of some of the most brilliant people I have ever met or worked with. So it's not hard to show up every day for work. About half of them are engineers, and the other half have their PhDs and master's degrees in all sorts of science fields that are related to everything in between the sun and the earth and the earth systems. And I'll get to tell you more about what they do, how they think, and how we're serving the planet in our everyday work.
Awesome. Well, why don't we get into it? And why don't you start sharing your screen?
Sure, I would love to. So just a couple clicks away. I always feel like I'm sort of in mission control when I do this. So just let me know when you see the slides come up.
I can see them here on my end, so I think
Hey, thanks, Marley. So it's about a 3-second delay. I just calculated from the time I clicked said that. So you can see sort of, yes, that is the title below. But just imagine a lot of great thinkers, very, very concerned about the planet. And so I always want to talk about the, I'm gonna click again. I'd like to talk to you today about these superheroes that you see on the screen. Now, you might have always thought about satellites as just hardware, lots of bits and pieces. For me, they're superheroes, and each one of them has its own superpower. And if there's one thing I want you to take away today, is to at least talk about the ones along the bottom that skim the surface of the Earth here. Those are Canadian satellites. They were built, they were first created and conceived by Canadians, and then they were built, and now they're flying up above our heads 24/7, monitoring the planet. And what's really special about Canada's expertise, it's in an area called synthetic aperture radar. So that's a big mouthful, but you can remember the word radar, satellites. And they have this incredible superpower. They can send those radar signals down onto the planet, receive them back, and build a 3-dimensional map of everything on the planet through clouds, through all the weather, 24/7. These satellites are at your service. And I will talk a little bit more as we go through, but they really are monitoring everything from ice extent and the waters. They're monitoring ecosystems and keeping you healthy and safe. It seems like there's almost nothing that these superheroes can't do. And the ones on the side, the triplets, I call them, they're the constellation that was just recently launched, just 2 years ago now. But the one in the middle, RadarSat, this is the older brother. The older brother that was launched in 2007 was like a precursor. It was out there doing the job and convinced us we need to send out more. So the ones on the left, the triplets, they're very new, they're very recent, and they're doing even more. They're even able to monitor ships that are out at sea. They're able to detect illegal fishing. They're able to detect just about anything you can imagine. And what's important for the audience today is to think about what kind of problems would you want to solve for the planet? And could our satellites help you? Because they do incredible things. I'm just going to talk about a couple of, I could talk about them all day because I get very excited about satellites. I'm going to talk about SciSat as well over here on the right. SciSat does something very different. It's up in the upper atmosphere and it's observing the molecules around it, it's checking for the greenhouse gas and the health of our atmosphere, and it's contributing to indicators of how the health of our climate is. So that's SciSat. The ones all up on the top, Canada contributed instruments. So we send an instrument to go up on the satellite of one of our international partners. And so we have, I'm just going to name off the countries that we worked with. So Odin was from Sweden. We have SWAT that's being launched just next year with NASA and the French Space Agency. Superpower it's an altimeter, so it's sort of in terms of height and detection. It's going to map every single body of water on the planet, which has never been done. We do not know of all the bodies of water on the planet, believe it or not. CloudSat in the middle with NASA that's monitoring that. I'm not sure if you knew, but there's a major link between clouds and climate. And that satellite is giving us information about that, informing us daily. SMOS with the European Space Agency, and Terra, the last one, but not the least. Terra is chock full of instruments, has 5 superpowers. It's mostly built for climate, answering questions to climate issues. But NASA collected together all of the instruments from international partners and put that out there in 1999. So it's maybe the oldest, it's the oldest on the block. Yeah, I'm looking around here and wow, it's a 22-year-old satellite. That's pretty good. That's a pretty expert satellite. So there's the fleet. We haven't talked about what they do yet, but there's the fleet, Michael and Marley. What do you think?
Pretty amazing. You know, I think we have a model of RadarSat actually in our gallery space, and you know, of course, one of the first things that stand out are just those big, you know, solar panels along the sides. So really, you know, I guess the first question I would have sort of on this, you know, the RadarSat constellation mission, are they always like really close together like that, or are they on different parts of the Earth when they're orbiting around?
They're in this amazing polar orbit. So let's think about this for a minute. Polar orbiting satellite doesn't need to move because the Earth turns. So it's painting the Earth as it goes, and they are spread out in a strategic way so that they can, as a constellation, they're sort of contributing to each other's readings, and then they're making a more full reading as they go along. So you get better coverage, better time swaths as well. And they're 24/7 going around and monitoring so that we get multiple readings across Canada every day. And we work with international partners. If there's an international disaster, and we're part of something called the International Treaty on Disasters, and we immediately turn our eyes to the place on Earth. As soon as we're over top of it, we're reading on those critical places that our partners need readings from. So there's quite a collaboration internationally on these satellites.
Awesome.
I have a question for you, Taryn. You said that the Terra mission are 22 years. Is that like an average lifetime for a satellite, or was the mission just extended? Like, did it just work really well?
I mean, honestly, almost never would you as an engineer sign up for a 22-year mission. Parts just don't last that long generally. And so we often say 5-year, maybe a 10-year max. And this is a great question, Marley. And SciSat 2003, that was a Canadian mission. I believe we said 5 years. And here we are going strong. And we are reporting on the Montreal Accord and the Paris Treaty. We're just giving so much data that's so valuable, and it's still going strong. So that's a very good question. These are overextending their lives. The Canadarm is a good example, was supposed to be a 10-year mission. We celebrated the Canadarm 20-year anniversary this week. These engineers, they know how to build quality and reliability. And one could argue, wow, they're overbuilt. We overbuild. It's really, the goal is to build the best thing that we can so that it does exceed its lifetime.
So because like they're built to last, but are there ever any plans to replace these satellites if the mission lengths are so short?
Yeah, you mean replacements and follow-ons?
And follow-ons, yeah.
Yeah, RadarSat in the middle, actually, there was a precursor, RadarSat 1, and because it's been decommissioned, it's not on my picture, but that's back from the 90s. And then we did so well, Canada did so well with synthetic aperture radar that we decided to build another one, and that's RadarSat 2. We did so well with that, we decided to build the constellation. So that's a great story of continuity and multiple successes. SciSat over here, there's a whole lot of us who are cheering and hoping for SciSat 2. We see the great needs, especially that, you know, climate has become such an important issue. Back in 2003, you can imagine the decisions were made in the 90s to build that. It was launched in 2003. We had a lot of foresight to be building something. It's a value for Canadians, the climate. And SciSat back in the 90s, had already recognized the need for monitoring our climate as a nation. And here we are still reporting on those really important indicators that are being used internationally.
So Taryn, we actually have, before we move on from these satellites that are so cool, so we do have one question from Clive, who wants to know, so of all the functions or superpowers, as you call them, these satellites are capable of, which one is your favorite? So aside from like the satellite, but of the actual function, which function or superpower is your favorite?
So Clive, thank you for that question. And I'm going to scroll down, and bear with me because the scrolling is a bit, it'll take a minute. I need to get down to wildfire sat. And so wildfires, how do you monitor for wildfires? You need to feel the heat. So we have a concept. It's not in the sky. It's still a concept. Canada has an expertise in microbolometers. In other words, it is detecting heat. We are looking for hot spots before the fires are lit. But when the fires are raging, we are informing, and this is a concept, we're informing firefighters, first responders of where the most urgent, highest heat points are. This is another one of the polar orbiting satellites, and it would be painting the country, covering all of Canada every single day and informing first responders. We've been encouraged to continue this concept. These concepts take a couple of years to really get down. We're working with Natural Resources Canada and the Canadian Forest Service, and we're all establishing what this satellite would do to be fully and truly useful for whatever operational life, like Marley said, the 5 or 10 years that it could survive, what would be the greatest need and the greatest use of this satellite. So we're studying that and informing the decision makers so they can tell us, okay, you're good to go, and we would build it. So microbolometers is something kind of new on my radar as well recently. Detecting heat. I think that's pretty cool.
Yeah, and obviously very important, for our part of the country and for where Marley is as well. Like we've had some really bad forest fires over the last couple of years, so I can see why they've really prioritized this, and I really look forward. Hopefully this project goes through.
So do I, and our international partners are all asking, can you get data from our country too? And that's tough. That's a bigger satellite that requires more constellation of 3. Like this is where engineers, they have to keep expanding the design, the more demands there are. So of course the answer to the international partners is it would be nice, but it has to be considered in the design because it grows very quickly. Also, apparently I've been told, the best time to monitor those satellites is the middle of the afternoon. So if you time that it's always over Canada in the middle of the afternoon, what does that mean for the Southern Hemisphere? Well, they don't get the prime readings. So there's a lot that goes into the thinking and the design of a satellite that most people might not consider.
Interesting. So we've got about 12 minutes left with you, Taryn. Did you want to go back and share some of these amazing photos that, I mean, of course, that's sort of like the real good stuff, I mean, like we've got all this data.
Right? Yeah, it's really like, the takeaways. I want people to be able to say that in case of floods and disaster, those satellites, they help chart the routes to safety. They're constantly at the rescue, really. They're also part of the rescue. And public safety counts on our satellites to give that kind of data, whether it's flood, fire, hurricane and destruction anywhere, earthquakes. And I just said hurricane, so there's a nice. Did you know that our satellites can actually detect moisture? And we could tell you if one corner of your field was drier than the other, and we could help you decide what would be the best irrigation watering methods so that you don't waste water, and more importantly, that you're not wasting fertilizer and chemical products where it is unnecessary. Just a few more. Oil spills, another really great use of satellites to look over areas that are so hard to reach. Ice maps, you might not know, but Canada produces ice maps, almost like weather. We're producing ice maps. And that's through the Ice Service at Environment Canada, and it helps keep the ships safe. And as the ice is melting up north, there are more and more ships going through the Northern Passage. And here's one that you all love. the polar bears and the ice extent. It's important that we're monitoring that thickness of the ice and the extent of the ice. Our satellites are giving you that information. And I think I'll just pull coastal erosion, part of climate change, really important to know. If you had a house built on that coastline right there, you'd want to know when that line is receding. And I'll just give one more, Michael, and it's going to make me scroll down, I think, just past these ones to a final story about whales. Recently, the Department of Fisheries and Oceans asked us, is there any way you can detect our whales? And our experts in synthetic aperture radar said, it's really hard for us to do that. The whales only surface momentarily, and it's hard to tell the difference between the back of a whale and a wave. But let us talk to our international partners. Maybe there are other satellites that could come to the rescue. And this is a point that I want to be a key takeaway for everybody. It's not about monitoring and surveying in the moment. Sometimes it's about prediction. And so we're talking about making models using the satellites that can monitor the quality of the water, and where algae is blooming. We can say, there will be krill there, and the whales eat krill, and therefore the whales will come. And therefore we can predict where the whales are going next. And we get crazy kind of data maps like this, or movement of water. And in that way, we're looking at how we can predict where whales will be so that vessels can stay out of their way. And we can save the right whale. That's been such a problem. Over 1,000 were killed by boats last year. We're working together, and the audience would love to have your brains involved in problem solving using satellite data in the future.
Wow, amazing. Of course, yeah, if anyone out there on YouTube, we've got about 9 minutes left. If you want to get in here, ask Taryn Tomlinson some questions, put them into the chat. I've got one. I don't know if Marley has any more, but, I'm curious about, say, people that are working with these animals, and they come to you. Now, when they say they come to you, are they coming to the Canadian Space Agency, or are they coming to the government as a whole? And are these government agencies working with each other? Like, I'm curious about like the interworkings of like how, everything kind of like fits together.
I love that question, because that's what I dedicated my life to for the last 2 years. I was working as chief of staff to the president, and the president said, I want to sit face to face with my counterparts around Ottawa, and I want to ask, what's keeping you awake at night? And then I want to see if we can solve it with our tools. And I kid you not, he gave the task to the vice president of the Canadian Space Agency, who borrowed me for 2 years. And we went from table to table and asked that question, so to speak. We had some intelligent discussions, but overall it was, what keeps you awake at night? And Aaron McPherson, who is a vice president at the Department of Fisheries and Oceans, looked at us and said, can you help us with our whales problem? It was one of those situations where we're going to have to go back and ask. And that is literally the conversations that we're having in the federal family. We call it the federal family. It's all the departments at the federal level. And you can think about Environment Canada, Natural Resources, Agriculture. The Department of Defense is one of our biggest partners. And those conversations with them are happening constantly. We're always working together. But there are 15 others. There are so many non-conventional departments that I would never have thought of who could really use our data. And they've come to the forefront. And those are wonderful new relationships that we've established, and everyone's thinking for the future.
Absolutely. That's a great point, because even with us at the Space Center, we are usually looking out into the universe, looking out at, planets, nebulas, galaxies, everything that is out there. And, a day like today is a good reminder that on any given day, we are also talking about our planet. And usually we are kind of like relating it back. And sometimes it just takes a slight shift in people's thinking to remind them that the Canadian Space Agency, one of their main roles is to look back on our planet. And if people have concerns and have ideas, or say things that keep them up at night, that the Canadian Space Agency would be a place that you'd want to go to, right?
Absolutely. And it is a major part of our mandate, is to solve problems and use scientific data to solve those problems, evidence-based information that we provide. And now we're talking about, I mean, what comes down from the sky is big data. So if we can learn how to learn from the data, we have decades of data available. We can learn and process that data and do the analytics. It is the key job for the future. And I talk to a lot of youth these days, and I keep trying to remind them, data analytics and thinking about all that data coming down from space. It's a gold mine. It's really just what's the problem that you want to solve is really the first question you need to ask yourself. And after that, can you use space data to solve your problem? If not now, in the future.
Okay, so in our last 5 minutes, I'm going to throw this out to our audience. I'm going to also throw it to you, to Marley. When it comes to the Earth, what is something that perhaps keeps you up at night that perhaps Taryn and her team might be able to solve? Is there something that comes to mind that you think about when it comes to the Earth and perhaps observing the Earth? And of course, this goes out to anyone out there in the audience. Put your ideas in the chat. Marley?
One thing that's definitely kept me up at night most in recent years is floods and fires. Those two tend to really get me a little terrified, because there was a big flood in Calgary not a couple of years ago. But I'm wondering, Taryn, you said they help chart the path to safety. Can the satellites also chart like potential flooding zones and areas to look out for, or things that may flood in the future, like glacier melt and things like that?
Marley, I'm so glad you asked that question, because I didn't get a chance to talk about the flood maps, but satellites are so key to the government of Canada producing flood maps and flood zones. And you can get access to those, and you can find out if your backyard is a potential flood zone. So this is preventative. So that information is available. It's preventative. Yet we also respond in the situations when there's an actual flood, and I did discuss that and talk about that, and we can get such accurate data about that flood extent. And then, of course, ice melt up north. You're asking the question of what can we expect in the future? Well, absolutely, we need to keep monitoring. We have to do a better job of monitoring and protecting the glaciers, and we are watching the ice melt. We don't have the solutions, but we can contribute to the information so that decision makers can choose the best solutions. I love that question. Flooding, it certainly does keep people up at night. It's if you've lived it, it's a nightmare.
Yeah, there's something terrifying about watching a house flow down a river and hit a bridge. It's just terrifying. And then I guess with the wildfire satellite that's in the works, my big question is, if you're looking for heat signatures, they'll have to protect from the sun somehow, right? Will that impact signatures they get from looking at Earth?
Yeah, that is such a smart question, and I won't be able to do it justice, but a microbolometer has a sensitivity that is, if I can use a pun, out of this world. And the ability of the microbolometer. Now, here's an interesting chain of events. We never send something on a satellite that we don't test first. How do you think we test, Marley?
Here, right?
Yeah,
somehow.
What can we use in the sky? What could we use for testing?
Oh, the satellites you've already got up there.
No, actually, lower down.
Oh no, this is too on the spot for me.
What could hover?
Like helicopter, something.
Yeah.
Okay,
helicopters, airplanes. Yeah, you got one, Michael?
Drones, perhaps?
Drones are a great one. And you can imagine the firefighters make great use of drones, but there are drawbacks of drones. They're expensive. They can't go everywhere. They only are so high up, but we test all of this technology on the drones first. And then that technology, we decide whether or not we can go further away and still get the readings, and go further away and detect. So it's really a process, and you can imagine all of the different groups of engineers who are designing at every level, literally at every level.
So our final question before we wrap up this show, Taryn, is from Pride, who asks, what about the shifting Gulf Stream? Is there something that the Canadian satellites are looking at with that stream?
You've caught me on that one. What's the shifting Gulf? Oh, you mean the weather patterns? Oh, sorry, weather patterns, of course. So satellites are highly involved in weather patterns, weather forecasting. So another big word, the main words with satellites is really monitoring, surveillance, forecasting, prediction. I haven't talked about forecasting, but that's exactly right. Forecasting. Now, this is where I get to share with you Canada's weakness. We do not have any weather satellites. We count on mostly US weather satellites. Because we're friends, we get that data. But it is definitely an area that we're concerned about. We should be building our own weather satellites. But to answer the question is yes, we rely on the information. We have modeling centers at Environment Canada. The weather system is right out here in Dorval in Quebec. They have supercomputers. We're known for these incredible high performance computers that we have here at Environment Canada. And we use models for forecasting, and we compare the models with our international partners. And in a recent hurricane situation that was being predicted, I went out to the center here and I saw the data analysts who were at their computers showed me, this is what the US predicts. This is what Canada predicts. This is what the Europeans predict. This is what Donald Trump Sharpie predicts, but said these are all the different predictions, and we believe that our model is the right one. And there you go. Canada has expertise in modeling.
Wonderful. That's almost at the end of our time. Taryn, thank you so much for joining us on Ask an Astronomer, Marley's first Ask an Astronomer. This was great. Taryn, where can people learn more about what you're doing and what the Canadian Space Agency is doing with all of these satellites?
Our website, please come onto our website. It's chock full of fun things and games, and use the data yourself to solve problems. They let you try things out. It's pretty interactive. It's really cool. So please come to the website.
Absolutely. I regularly go on there when we're pulling some of this data when we're doing our programs here. It's a really great resource to use. For all of you out there on YouTube, thanks for joining us on this Earth Day. We will be live right here on YouTube in 2 weeks, Thursday, 2 p.m. Pacific time. And when you go to our website, spacecenter.ca, you will see that we are open, not fully open, but we are open to come through our gallery space. Our observatory is open. You can book a time from Thursday to Monday. Our next online event is on May the 4th. Can you guess what the theme is on May the 4th, Taryn?
The theme on May 4th?
Yeah, this is the test. May the 4th be with you, Taryn.
May the 4th. You got me.
We are talking all about Star Wars. So if you get onto our website, you can book a ticket. We have an amazing guest that's going to be joining us from the Industrial Light and Magic, ILM, and that's the people that create all of the special effects on Star Wars. And Marley's going to be doing a presentation that night as well. Come on in, join us on the evening of May the 4th. Thank you all so much. Thank you, Taryn. Thank you, Marley. We'll talk to you all.